This is a follow-up webinar really to the one that we did previously with HSM. Is to just give you a bit more of an idea of the new products that have come into the product design and manufacturing collection recently. First came in August. Most of you know me. If you don't, I'm Ollie Lewis. I'm one of the sales consultants at Micro Concepts. Joining me today is Thomas Larson from one of our from the Future Group. He's going to be doing a live demonstration for you. So if we could commence, you want to click through to the next slide, Thomas?
Yep.
So if you haven't come across me before, I'm one of the sales consultants, one of the account managers here at Micro Concepts. Part of my role is to introduce Autodesk solutions to new customers. Also work with our existing customers to help get more from the Autodesk products, may that be through training, consultancy, support. I've got experience implementing solutions the whole way through the product design and manufacturing range. So that's everything from 2D CAD through to Inventor, AutoCAD, electrical, data management solutions as well. If it's your first time coming across Micro Concepts, the business has been running since 1989, got over 25 years of experience in engineering and management solutions. We're an Autodesk authorized training center, so we offer training on basic level Inventor and AutoCAD courses, all through to design automation, data management, that sort of thing. And we're also one of the few AutoCAD electrical specialists in AutoCAD products. Yeah, go through to the next slide, please, Thomas. So this is where it's all started, really. Autodesk, they've condensed down their product range. We used to have many different variations of the suites which we offered. Now there's 3 industry collections which are available to the customers. A lot of the customers that we deal with now, it will be the product design and manufacturing collection that they're using. This is stemmed from a collaboration of tools from the product design suites and the factory design suites. And like I said, in August we had Nastran In CAD added to the collection and HSM as well. So I think from speaking to a lot of you, you're already using the FEA tools from within Inventor itself. Where Nastran comes into it is it builds on those capabilities. So you've got nonlinear FEA within it, you've got thermal simulation. Again, it's a product that sits inside of Inventor itself, so it's in a design environment that you're familiar with. With HSM as well, we did a webinar on that a couple of months back. That's your 2.5 to 5 axis CAM tooling. But if you have a look at the products that are within the collection, it's pretty much the product design suite ultimate that you're getting, with the addition of the factory design utilities, AutoCAD architecture, and then the 2 new products which have been added. Next slide, please, Thomas. And this is where they're going, Autodesk are going with it. It's one collection that can suit everything pretty much. So you've got Inventor in there for your 3D design tooling. You've got Nastran In CAD to do your simulation work. You've got HSM to do your tool pass, generate your G-code for any manufacturing work that you're doing. And then you've got factory design tools in there where you can bring in point cloud data, you can do your layouts. There's a really nice workflow from AutoCAD through to Inventor or Navisworks. So it's about having one package that can cover a lot of ground with a product design and manufacturing collection. Next slide, please, Thomas. Go through them. My email address is there as well, so if you have any questions at the end or want us to follow up on anything afterwards, please send them through and I'll be in contact once the webinar is completed. But for now, I'll pass you over to Thomas and he'll show you a bit more of the capabilities of Nastran In CAD.
Thank you.
Thomas.
Yeah, thank you. I hope you can hear me.
Yeah, loud and clear.
Oh, that's good. So as Oliver said, we have to talk about Nastran In CAD today, and I have made a little agenda. First, a little introduction about myself, then why we should use Nastran In CAD. What is the difference between Inventor and Nastran In CAD? Some Nastran functionality. And then I will make a live demo. Today it will be a more simple one because it could be time assuming to do one of the bigger one. But I will show you how to, in Nastran In CAD, create a bulk connection, do some linear static, and then we can, when we are finished, we can do a report. So a little bit about myself. I have been working with Autodesk software for at least 15 years now, mostly Inventor and a lot of Vault. And for the last couple of years, I have also been looking at Fusion 360. And I have done a lot of simulations in Inventor, and now we are looking at Nastran In CAD as well. So why Nastran In CAD? Yeah, we can do bulk connections. We can have we can do simulation with sliding interfaces and frictions in assemblies. We can use time, which is not a possibility inside Inventor itself. To do it could be vibrations or fatigue. We can work with temperature, so we can have heat transfers as well. And one of the big difference between normal Inventor and Nastran is we can work with nonlinear materials. If we look at it in a funny way, Inventor simulation, that could be a scooter. And there's more, what should we say, more advanced tools than Nastran In CAD. That could be a Formula 1 car. And in between a scooter and a Formula 8 car, we have Nastran In CAD. It's very easy to use, and it's inside Inventor already, so just use it. The difference between Nastran In CAD and Inventor simulation, they're both embedded inside Inventor, and it could work with other CAD than Inventor itself. They can both do linear, and they can both do model analysis. And then it stops. In Nastran In CAD, we can do thermal, fatigue, buckling, composite material, random vibrations, and so on. One of the other things that we can do drop testing. I see a lot of people doing that, so that could also be a good one. And another difference, it says that both can do linear, but in Nastran In CAD, we can do linear and then also take in time as a factor. And we can't do that inside Inventor. So here are some of the different, the ones we can do. Linear statics, we can do buckling. Buckling could be used to assess the stability of a device under loads. It will examine the structure of a sudden failure. Then we have normal modes over here, if you can see that. That's to determine the undamped natural mode shapes. And if we take another one down here in the left corner, that could be a heat transfer. If you put on some temperatures and see how they will be, how they will react in the parts or in the assembly. And then we can call them a little bit more advanced one. Again, nonlinear heat transfer. Or down here where we can see how complex contacts between two parts can affect. And of course, we also can do frame element, what's it called? Do FEA on frames as well. So there's a lot of different things we can do inside Nastran In CAD. And down here we have a drop test of a mobile phone to see if it will break. And if you have an iPhone, you know that the glass will break every time. So when we do a simulation, we first create the part or the assembly, then we assign some material. We could create a mesh first and then apply loads and constraints. We could also do it the other way around if we want to. And when we are finished with the mesh and the loads and the constraints, we can run the simulation, and then after a while we will get a result. And why should we do it? We should do it to reduce errors or improve performance or optimize our cost. And the good thing about Nastran In CAD that we can do it up front before we even have made our part or assembly. So in my little short demo, we are going to see if this plate is strong enough. And it's a front bumper of a car, and on top of the plate we will put this standard winch. I can see here that it has a motor with a 1.6 horsepower, and it has a pulling rate of, let's say, 1600 kilos, and the weight of the motor will be 11 kilos. So let's create a plate and see if it's strong enough to have a pull rate of, let's say, 1600 kilos, and the weight is 11 kilos. So here we are, back in Inventor. I open up my small assembly, and you can see here is the motor. And just to simplify, I have made a level of details prepared for my Nastran In CAD demo. So here I got 2 plates, and if you see, I have put a work point here, and that's the center of gravity for the motor. So I will change under my environments and go to Nastran In CAD. And as always, start from the left, go to the right. And I have my browser, where down here I have my model, and up here I have my first analyze. I can do several different analyses, but I only have one this time. It could be that I will do some different ones with different materials or whatever. So this one, we will say, I will make sure that these 2 plates are made of steel. So I just drag a window and it collect them down here and say, now they are steel alloyed. So that was the first part. Then we go to constraints so we can lock it up. And if we just take a look from the left, I will say I will lock some faces. And instead of pointing out every face, I just drag a window and do the same up here. So if we just turn it around, we can see I have locked the bottom face and the top face up here. And I can say if it should be fixed or free, no rotation or pinned or whatever, but in this example, I will say the faces are fixed in every direction. And to make it more realistic, I will put on a load. And I have different loads that I can put on. And in this example, I will do, say, we have to take gravity in. And I can see down here on my user icon here down here that it's in the Z direction. And now we can see down here in the right corner that gravity is put on. And when it comes to a simulation, we also have to take care of all the contacts between every face. I could do it manually, or I could say I will do it automatically. This is a very simple one, so it will only be around here. So I take automatically. And over in my browser, I can see now that I have 2 surface contacts. I have one down here with that face and the back side of the red one. And if I take the other one, oh, sorry, it's that face and the fillet down here. And if I edit them, I can see that they are bounded, but I will change them to separation. And I take the other one as well and say it's also separation. So now when they do the calculation, they can move from each other. But I will make a bolt connection. So if we go down here, let's say where I have put it. Down here I have connectors. I will make a new one. And again, we have different types. And for this one, I will make a bolt connection. So I will tell it to start on the edge here and stop on the back side. And if we look again from the side, it have put in a 12 mil bolt. I can tell it that I need a washer on one side and a washer on the other side. Just change the color so we can better see it. And we can put on a preload if we want to. Let's say 2500 newtons. And then I will put in a bolt and washer in the other 3. I can make them one more time, or I can say I will create a duplicate. And then I have to say the start is over here and the end is here. And we make a new copy. Start down here and end here. And the last one, start over here and end. Oh, sorry. Here. So now we have 4 bolt connections, 12 mil, 2 washers, each with 2 mil, and we have a preload that is 2500 newtons. And because we don't have the motor in here, we can do a rigid body instead. So if I go down here and say I want to make a new connection, and instead of a bolt, I will create a rigid body and say that I know it will be secured down here in these 4 holes. And the center of gravity is up here. Again, we can change the color. So now I have locked the motor in the center of gravity in all 4 holes. And if we remember from the slide, it will pull with approximately 1600 kilos. So I will put on a load, a force in the center of gravity, and the direction will, if I look at my UCS, it will be in the X direction, and it will be 16 kilonewton. And let's say, see, this seems right. So that's okay. And I know from my slide that the weight was 11 kilos. So I can make a concentrated mass. Instead of drawing something, I can make this one and say 11 kilos. And it should put them also in the center of gravity. So I don't need the part of the assembly. I can just put in this one as a reference. So now we should be ready to do some calculation. So before we do that, we just have to control our mesh settings. I will change the size to 8, and I want them a little bit smaller than normally, so I'll say 0.3. And then I will tell Nastran to generate the mesh. So now that's done. And then we'll have, now we put on the solver to run, and it will take around half a minute or so to do the calculation. And when it do the calculation, we can go back to the browser and have a look. You can see down here in the model, I can place several different materials, so I can make different runs to check if one material is better than the other one. And I can turn on and off different solids if I want to try a calculation with or without a part or another subassembly or whatever. So I can store several different things down in the model and only use some of them in one of these analyzers. So let's see if it's finished. It will take 10 seconds more, I guess. So now it should be finished. Yes. So now we have the results. And if we want to look on, for instance, the stress, and I can say display. It's very, very high, so we have to do something. We can just make an animation of it if we want to. Now it will create a small video for me. Just give it a second. You can see down here it's a animation setup. So now I can see how it will react. We can stop the animation and see instead of stress, we will take displacement. And once again, display. We can see that it will bend 10 mil down here. So we probably have to do something just to see if we can get a better result. So I will say, okay. I will jump out of Nastran In CAD. I will go to this part and say open. And change the thickness. Now we have a 6. I will change that to 12. Close the part again. Yes. Do an update in the assembly. So now we have a much thicker plate, and then we go back to the Nastran In CAD. And the only thing we have to do now is, because it has removed the mesh from the red part, we have to make a new mesh. And then we can do a new simulation. And once again, we have to wait half a minute, and then we will have a new result. And when we have done the result, and if we are satisfied, we can go up here and right click and say we will generate. Now it's not there, but when it's finished, there will be a report there. And then we can export everything out as a report with all pictures and the result. So we can use that for documentation if we want to. So hopefully it's soon finished. But again, if we go back to while it's working here, we can see up in the toolbar. First thing you do is pick your material, If we have frames, we can do structural members. Then we have to constrain it, put on some load, contact, and mesh. So it's always start from the left and go to the right. So it should be, I don't know if it's easy, but because you have to know where your loads and contacts are. But it's pretty straightforward to do. So now it's done. Hopefully. Come on. Yeah, there it is. So now if we take the displacement, before it was 10, let's see, now we're down to 3. And we can have a display if we want to. And if we take a look on the stress and say we want to see the furnaces, now we're down to 61. Oh, that was a beam. That was not the right one. I was just being blind. So we can see now it's 544. If I want to change the color, say I will have the red ones. Now the red is 544. I will change so everything that's above, let's say, 300 should be red. Then it will change the color on the assembly. So we can see down here around the 2 holes here, we have the problem. We can just turn off that one and that one. And we could check the load as well. That gives us a more clear picture. And if I want a more detailed overview, I can turn on probes. So if I just put my mouth on the mesh, I can see the different examples, how it reacts. And let's say that we are satisfied with this one. We can hit the OK button. Then we can go over here and say generate report. Put in a title, a date, who's the customer. We can fill all this information in. We can do a summary. We can do some assumptions. We can make some different text here about the mesh and the contact definition. And when we're done, we can say go, and it will create a report. And now it will take some pictures of all the different states. I forgot to save, so now I have to save during the report. So now the report is finished. So now we can view the report. And it's an HTML page, a lot of different pictures. What have we put up before? What is our contact definitions, our material, and so on? And what was the result? And of course, if we do some changes over here, we have to do a new calculation and create a new report.